Hello, my name is Joel Phillips, and let me welcome you to this webinar entitled Bridging the Dimensions of Authentic Science Learning. Please feel free to scan the QR code on the left so that you can get access to the webinar materials. At the time of this recording, I am a high school chemistry teacher at the Springford Area High School in Royersford, PA. Allow me to give you a little bit more background about myself. I taught 9 years in Philadelphia School District, and I've only been at Springford for 1 year. And so also I'm a former biomedical engineer in orthopedic implant research, and I've been an advocate for the Society for Science for 3 years. I've done curriculum collaborations with professors at University of Pennsylvania, Yale University, and Temple University. I have delivered district-wide science PD in Philadelphia, both in person and virtually. And finally, I'm finishing up the certification as of May 2025 in socio-scientific and socio-transformative constructivism framework of instruction. And hopefully you'll get a taste of that today. So what are we getting ready to dive into? Well, our objective today is to identify strategies for implementing authentic science learning in order to discuss applications and potential impacts on classroom practices. Now, the overall concept to make this work is that authentic learning requires balanced perspectives. And you're going to see that as I go throughout the presentation, we all have different perspectives on what authentic science learning looks like. So we need to make sure we know where we fit on that continuum so that we can evaluate our own teaching practices. So today's roadmap includes defining what is authentic science learning, integrating socio-scientific issues, applying science discovery narratives, practical applications and assessments, and finally, collaboration and resources. So this is the general consensus in science education. If you differ, that's okay. It's widely recognized that we most likely agree that all of our students need more authentic experiences, but I think we differ in what does that actually look like in the classroom. So there's actually a disconnect between what is learned about science in primary and secondary education and what is practiced in the collegiate and even the professional settings. Let's start by defining what are the two dimensions of authentic science learning. The first is the most practical. It's probably the one that we do regularly as science teachers, which is technical authentic science learning, or technical ASL. It involves a complex set of activities that scientists actually do in order to do science. I think we can all agree we want to give our students these experiences, and those experiences actually focus on actual technical skills such as pipetting, doing a titration curve, even learning how to mix solutions together. However, this other side of authentic science learning might not be so inherent to every science teacher. It's the cognitive ASL. It's about making scientific content relevant to students' lived experiences, and it focuses on developing comprehension skills in students. If you are a recent and relevant science teacher, then I think we all agree that we want to make these experiences connect with our students' lives. We want to show them how the science connects. However, I don't think we necessarily do a good job at focusing on the comprehension skills. We focus more on the technical ASL, but we actually, deep down on the inside, want our students to relate to the content and the skills that we're teaching. So as I go through this webinar, you're going to see me use this color code, the teal for the technical ASL and the magenta color or the rose color for cognitive ASL. So where are the opportunities concerning ASL? First, there has been evidence in the research stating that ASL has positive effects on academic achievement. That's wonderful. However, there's very little evidence of ASL and its effects on STEM career aspirations. So we got to work on that. The reality is when we teach a STEM class, our students perceive it from a technical learning level. They don't think of it from a cognitive learning level. And we have to be conscious enough to bring them into the cognitive, authentic science learning experience in order for our students to actually have career aspirations that are aligned with STEM. They may not actually become scientists, but we still have STEM related fields that don't actually require any technical skills in the laboratory at all. So the first tool that I want to show you to help you introduce cognitive ASL in your classroom is called the SSI star chart. SSI being socio-scientific issues. As science educators, what we can do with this star chart is help our students map out what are the scientific, economic, political, religious, and ethical connections to a scientific phenomenon or science discovery narrative, which I will get into later. You may have to actually spend time defining what does this look like with students in order to make this happen in your classroom. Now, let me show you how I would introduce this into my classroom. Newsflash, you may have been exposed to lead. So let's actually watch this video about lead contamination at a local school, and let's discuss all of the aspects concerning the star chart. I'm actually going to play the video, and as you're watching the webinar, I encourage you to take notes on any economic, political, religious, ethical, or scientific connections that you can make or questions that you can ask as you're watching.
Tonight, there are growing concerns over lead contamination in Trenton. It was found this week on a school playground and at more than 100 properties.
The city says it's now working with federal agencies to clean up. New Jersey reporter Ryan Hughes has more.
It's really concerning us because it's really dangerous.
Luis Reyes' stepson is one of the more than 500 students in grades 4 through 6 at Ulysses S. Grant Intermediate School in Trenton. School will remain open, but the playground has now been closed and blocked off with orange fencing after the city says above normal levels of lead were found in the grass and dirt behind the building.
It's the first thing he said this morning, like he's scared that something might happen to him with the contamination.
Trenton's mayor says in December, his administration requested testing by the U.S. Environmental Protection Agency. East Trenton was the site of more than 150 pottery factories, and the mayor says they left their footprint in the city's soil.
The standard is 200 parts per million, and the lead levels exceed in the ground soil up to 600.
The mayor tells CBS News Philadelphia the EPA's results released this week also found lead contamination at more than 100 properties near the Grant School. He says the blacktop and buildings serve as caps over the lead, but the soil will be excavated over the next few months and replaced with new topsoil.
We want this done right, and we want to make sure that the residents and the children are protected.
Doctors say children under 6 are the most at risk to repeated exposure to lead, and parents should speak with their pediatrician.
Most mild effects would be difficulty concentrating, changes in their behavior, sudden reading or speech difficulties.
The Trenton School District says it's now working with the health department to organize testing for both staff and students if families are interested. That information is expected to be released in the next couple of days. In Trenton, Ryan Hughes, CBS News Philadelphia.
So what are the signs and symptoms of lead poisoning? These are a few, according to Nemours Children's Health. You should look out for a loss of appetite, feeling tired or irritable, nausea and vomiting also, joint pain, muscle weakness, as well as headaches.
All right, so hopefully you came up with some things that you noticed in the video that were economic, political, religious, or even scientific. And so here's an example of what students would actually come up with in the classroom. They would begin to think about, ask questions like, well, did somebody know that there was lead already present in the soil before they built the school, before they built the playground? They even ask questions about, how will religion affect medical practices or medical treatment? One of the first times I tried this in the classroom, one of the students mentioned that, some people might view this lead contamination as punishment from God. And so it was so interesting because the students actually become free to express religious thoughts, even if it's not their own, but it allows them to even think about, whoa, lead makes me think about my religion, or like it makes me think about my relationship spiritually, things like that, or whether it's your own personal beliefs. So you can substitute religion with personal beliefs because not everybody believes in a particular religion. I'm just bringing this up because it's a powerful tool to help students actually make connections that matter to them and then hear their classmates' different perspectives. And you don't have to be good at science to do this. That's what makes this cognitive ASL. You can also apply the star chart when reading an article. I love to pull articles from Science News Explorers, published by the Society for Science. Speaking of the star chart, you can actually access a copy of it with the webinar resources. And it is one of the versions that I use in the classroom. Now that I've brought up using articles and not just a news clip, let's talk about the application of science discovery narratives. Science discovery narratives are basically articles that report a discovery. Based on research by Len Sigler, high school students were assigned biographies of scientists with different narratives. Achievement-based life struggle, or overcoming scientific struggle narratives. So 3 types of narratives. And what they noticed was that students who read struggle-based narratives demonstrated higher academic achievement. That's amazing. So reading science articles matters in class. So as we move away from academic achievement to perceptions and interest in science, this was also done with middle school students. The research thus showed that middle school students were more likely to ask questions about science topics when they read a SDN. The science discovery narratives also made the students feel as if the scientists that they were reading about were actually real people. There's evidence that suggests that there could be boost in comprehension skills, but there's still not enough to prove that yet. The correlation is not as strong as with academic achievement. It's just not strongly evident at the time of this recording. So now let me introduce to you another way that I can introduce cognitive ASL in my classroom. Imagine yourselves coming into class one day as students, and I tell you that I need you to reimagine yourself as kids on a playground. You're pirates looking for buried treasure. And so your goal is to go to the park and dig up whatever you can find in the dirt and bring it home as treasure. And so what I do is set up these treasure pools around the classroom that have red and blue beads, as well as actual trinkets. So they actually got to reach in there and pull the trinkets out. After they pull the trinkets out, I instruct the students to count the ratio of red to blue stones. I don't tell them why. I just tell them to report which ratio was higher. Did they have a higher ratio of blue or red? So I actually tell the students that all of you have been exposed to lead, but not every form of lead actually can become a contaminant to your body. Your body does not absorb every form of lead. So what I tell them is that if your soil type had more red beads in it, your soil had lead carbonate. Then I tell them that if you have more blue beads than red beads, then your soil was contaminated with lead acetate. Therefore, I can ask which form of lead is more poisonous to your body based on solubility rules. And then I can either ask the students to make a guess and try to figure out the rules on this list, or I can actually teach the list. Ultimately, the students come to the conclusion that those who were exposed to more lead carbonate are not at a higher risk of lead poisoning, while those who were exposed to more blue are at a greater risk due to the higher solubility. Again, cognitive ASL. And then, of course, now I can go into the actual lesson, give them a worksheet, just simply give them the ionic compounds and ask them whether or not these things actually dissolve in water or not, and give me the rule. But then let's take it a step further, because I don't want them to get disconnected from the authentic learning experience just yet. I have to begin to ask the students questions that make them reflect on the importance of the solubility rules. Like question number 6, adenosine triphosphate, ATP, is the chemical required to produce muscle contractions. Predict the effect that lead exposure can have on muscle contractions. And hopefully students will come to the conclusion that if lead combines with phosphate, it doesn't dissolve as readily, and thus it's harder to do muscle contractions because you have less access to ATP. Then I give them another question, still with phosphate, but in a different context. Now let's look at some technical ASL. What's the point of the flame test lab, honestly? What is the point? We teach about light. We might teach about electron configuration. We might teach about spectrophotometry. But how do we make this even relatable to students at all? Well, the one thing I didn't mention is that we use the flame test lab to help identify metal ions, right? I hope we were thinking about that. But that's technical ASL. So how do we make this more relevant and even associate this with cognitive ASL? Well, we have to introduce other components. We have to start asking our students questions like, how can we compare, or how do various tests of metals in soil compare to one another? So we not only have the flame test, but we also have a soil conductivity test, and then we have an X-ray fluorescence gun. And the thing is, the students are not going to know what all of these things are, but that's okay, because when we show them these things, it now becomes more real. I've actually had the students do the flame test. I've had them do soil conductivity, and I've had them actually collect soil, which I'm going to get to in a minute. But have you ever felt like you were giving away free grades as a teacher? I know I have. And part of the reason why we feel like we're giving free grades is because we're not actually engaging students in the authentic science learning experience. And so I've actually had to rewrite the questions for some of my labs to force students to either, hey, You're going to answer this question and meet performance expectations, or some of them just make the conscious decision and say, you know what, I'm going to try, but I'm not going to put too much work into it. And so now we're not getting students who are just copying answers. We're getting students that think. If they are copying answers, at least they are having discussions before they go ahead and copy that answer, because these are not just cut and dry questions that have clear answers. You have to think about what you did in the lab. One of those questions is just routinely asking students to make sure that their hypothesis was correct or not and to cite evidence. I think that's a pretty common thing to do. However, this is where we may not be so direct. We normally say, what are some sources of error? Or what could you have done better next time? I think we need to reframe that language and just straight up ask the students, what are the strengths and limitations of using the flame test lab to detect metal ions? What are the things that it can do? What are the things that it cannot do? What are the things that the soil conductivity test can do? And what are the limitations of the soil conductivity test? And because they did both labs, now they can actually cite their data from their experiment and come up with a proper conclusion. So here's the next piece: X-ray fluorescence. X-ray fluorescence guns can go anywhere from $10,000 to $25,000. So I don't know any lab at a school that has an X-ray fluorescence gun, but I do know somebody with an X-ray fluorescence gun. Nevertheless, I show the students this video and I'm going to play it for you to see right now.
All right, what we're doing is taking an actual XRF of the ore. This is raw head ore, never been treated, concentrated, or anything. Now, very rarely does it ever show gold in the actual ore. Now, you're seeing things popping up. The PD is palladium, the AG is silver, and this we very rarely test the raw ore, but we normally have some indicators that there could be other precious metals in it. So this is showing palladium at the top, 7.44. Oh, now look what popped up, 1.04 gold. Now it's 0.933, you see at the top. This is just giving an example that even our raw ore we can test to show gold.
Now that you've seen the video, it clearly shows how an XRF scan actually works on soil. And so now I can ask the students, can you explain why this technology would actually be more useful than any of the tests that you've done in lab? By asking that question, I have now bridged the dimensions of technical ASL with cognitive ASL. I am now making the students reflect on how a particular experience measures up to what they're actually experiencing in the classroom. How does a real scientist experience measure up to what they are doing? If we don't make them reflect on the gap between what's happening in the classroom and what's happening in the real world, then cognitive ASL never happens. So this is actually the bridge that gets created between technical and cognitive ASL. Thus, this is a project that I've worked on with my students, another practical application, as well as an example of community partnerships. I mentioned in my introduction that I've written curriculum units under the leadership of professors at University of Pennsylvania. And one of them actually collects soil samples across the city to do research on pollution. They actually work with the EPA. And so what I've been able to do is actually ask the students to collect soil samples. I give students a plastic bag, I give them a spoon, I show them the video, and I say, go get soil from specific locations like the windowsill at home or somewhere in a park. Make sure you get the GPS coordinates. They have those instructions readily available on their website, and they do it for free. All I got to do is ship the samples over. Here's the beauty behind this partnership. The lab tech actually put together a GIS map of the areas where soil was most contaminating the city. And this was with student-generated data. So now the students are actively involved in a community research project, a university research project, and it adds value to what it is that they're doing in the classroom. It's now authenticating what we did with the flame test. It's authenticating what we did with soil tests. It's authenticating the solubility rules now. And it's amazing to see it. But that's not it, because we have to consciously make an effort to make connections between what's happening in the classroom and what's happening in the real world. And so the students afterwards put together a lead safety presentation, and then they give it to their parents. And the parents fill out a questionnaire and bring it back. Now I get feedback from the parents on what the students are learning in class. And ultimately, this has potential to become a service project where students are now collecting soil from maybe their neighbors or from their cousins and giving it to the University of Pennsylvania, and they're analyzing it. And now people's lives are potentially transformed because they've become aware that, hey, I shouldn't be playing in my backyard. I shouldn't have my kids out there because there's a high exposure to lead contamination. And so this is the dream that I'm painting for you. This is the vision that I'm giving to you based on research. And there's still so much more we can do with our community assets or community collaborations. So there have been hybrid collaborations where college students use digital storytelling presentations on social media and in-person visits to the schools so that students get to interact with what's happening with college level scientists. Then there's even programs like Evolving STEM. This is a national program. It's reached 20 high schools last time I checked across 8 states. And there has been evidence of these authentic experiences improving student achievement in science. However, we're still working on collecting that data in regards to students' perspectives on science career aspirations. Hint, hint. Wow, we've reached the end of our time together already. That went by so fast. If you need more time to think about this stuff, if you want more PD, if you want to join me in the journey of what it takes to bring authentic science learning, especially cognitive ASL, into the classroom, and then bridging it with the technical ASL, then you need to scan this QR code and let me know what you're interested in. There are other professional development opportunities out there that are available for you to learn how to put this in your classroom in practical ways. If you know someone who would actually be interested in having professional development hosted at their school or at their district, then scan the QR code and let me know if you're interested. Again, my name is Joel Phillips, and my email address is listed below. And it's been a pleasure serving you in this webinar. And of course, we never want to forget that there was actual research involved. Have a great day.